Okay, so what I want to talk to you guys about is how we set up a force balance on a control volume. And the example we're going to talk about right now is when you have two rectangular parallel plates and the fluid motion between those plates. So a lot of times you see it drawn like this, where we have our lower plate at y is equal to 0 and the plate above it at y is equal to h, and in this case I'm showing a fully developed steady flow where there's only one velocity in the x direction, and it is a function of y. So if we want to set up a control volume on this situation, what we're going to do is we got rectangular coordinates. We'll set up a box, and this box will have, it's going to be delta x, delta y. So it's just a box of control volume that we pick in this location right here, and it's a cube. We'll just draw it in 2 dimensions here, delta x and delta y. And what happens is the pressure, as you've seen written, you have a pressure over here at x, then you have another pressure point pushing on this face at x plus delta x. Alright, and then you have a shear stress down on this bottom face, tau y x at y, and then you have one on this top plate, tau y x at y plus delta y. And I've had a lot of questions about how do I know the direction of these arrows? Why am I putting the pressure arrow this way, this one this way, this shear stress arrow going this way for this top plate, and this one going this way? And that's the main point of this video, is I want to explain how we set up these arrows so that you can do your force balance. Alright, so now here's a 3-dimensional cube we can use to talk about it. So this cube is basically the same as this drawing right here, and what I have here is I've made the unit normals, the unit outward normals for each one of these surfaces. So again, think about the flow again is moving through our control volume at this face and then coming out of this face. And so for our pressures, so for the two pressures, the pressures again, as I mentioned before, and using the Trusky Yuan Katz textbook and how they've set it up, is the pressures are going to be acting opposite of the unit outward normal. So this pressure is going to have an arrow going into this face right here because it's opposite of this unit outward normal for this this surface area. So then, and therefore on the other side as well, it's going to be acting opposite of this unit outward normal. So it's going to be pointing, both arrows are going to be pointing like this for the pressures. So that's our pressures. For our shear stresses, which act on this face right here and this one right here, if you remember in the drawing, we have the shear stresses acting on this bottom face is pointing in this direction right here, and on the top face is pointing into the other direction. And so the reason why is because on this face right here, this unit outward normal coming off of this face is pointing in the negative y direction, as you see here from our coordinate system. So therefore the shear stress is going to point on this face in the negative x direction, this way, right like that. Alright, and then vice versa on the top face. This top face right here is a unit normal outward pointing in the positive y direction, so therefore the shear stress is going to point in the positive x direction back out here. And so that's how we get this 2D kind of drawing of our different surface forces on our control volume.